So today we are going to talk about the first law in thermodynamics. Then in thermodynamics first law, we have the first law in cycle and also the first law in processes. So let's get it started. So the first one is the first law in cycle. So the first law in cycle tells us the heat transfer equals to the work, because for the cycle, we don't have anything else. So heat transfer must be the same as the work. Then we have an example for that. So the problem says the cycle has the work done of negative 4.7 kilojoule and determine the heat transfer of the cycle. So because heat transfer equals to the work, then the heat transfer of the cycle is going to be the same as the work, which is minus 4.7 kilojoule. Easy enough, right? Okay, so let's take a look at the first law in process. So we started off the first law in cycle, dq equals to dw. And for the cycle, we have two processes, from 1 to 2 as process A, and from 2 back to 1. So we could go with process B or go with process C. So let's take a look. So if we go from A to B, then it's going to be heat transfer equals to the work. The heat transfer of the process A plus the heat transfer of process B then equals to the work of A plus the work of B. Then similar thing for A and C, then heat transfer equals to the work. Then the heat transfer of process A plus the heat transfer of process C then equals to the work of A plus the work of C. Then we have two formulas. So if you use the first formula, subtract the second formula, then we have this expression here. Then we could rearrange heat transfer into work, put work on this side and the other heat transfer on the other side. Then we're going to flip over the integral intervals. Turns out to be we are here. Then from our previous class, so heat transfer and work, they are both path dependent. So they are a state property. They are path dependent. However, from this expression here, so it doesn't matter how I draw the process B and C. So I could draw with another path as well. So it doesn't matter how I draw the path. dq minus dw, it's always a constant. So they're always equal. Since dq minus dw is path independent and they're always equal, so we're going to define this dq minus dw as a new term and we call it as energy. So energy is defined as dq minus dw, then this is our first law. Then it's dE equals to dq minus dw. Although dq and dw, they're not a state property, so they are path dependent. The difference of that, which is energy. Energy is a state property, and you can find out energy from the thermodynamic table. So in mechanical, we have kinetic energy, potential energy, and also internal energy. However, in thermodynamics, so we probably only use internal energy so far. So it turns out to be our dE is going to be du, which is internal energy. So our first law is going to be dE equals to du equals to dq minus dw. So that's our first law, du equals to dq minus dw. If you enjoy what I'm talking about, make sure you like the video and subscribe my channel. Hope you have learned a lot. See you next time. Bye.